Thermodynamics. Thermodynamics. Isothermal process. Isothermal process. A process in which changes of pressure and volume take place. A process in which change of pressure and volume take place at constant temperature is known as isothermal process. An example is expansion of gas at constant temperature or compression of gas at constant temperature. For performing this operation process, the piston and the container should be of good conducting material, should be made of good conducting materials. The process, that is changes in pressure and volume, should take place very slowly, very slow process. Heat should be allowed, sufficient time should be given to flow the heat, for the flow of heat into the system or out of the system. Since temperature is constant, this process obeys Boyle's law. This process obeys Boyle's law. Relation for work done. Relation for work done. Work done by an ideal gas is given by W is equal to integral P dV under the limits V1 and V2. Integral P dV under the limits V1 to V2. From PV is equal to RT, we get P is equal to RT by V. P is equal to RT by V. Therefore, W is equal to RT by V into dV, RT by V into dV under the limits V1 to V2, under the limits V1 to V2. Therefore, W is equal to RT into integral dV by V, integral dV by V under the limits V1 to V2, under the limits V1 to V2. Relation for work done in isothermal process. We obtained the relation W is equal to RT into integral dV by V under the limits V1 to V2. By evaluating the limit dV by V under the limits V1 to V2, dV by V under the limits V1 to V2, we get log V2 by V1 to the base E, log V2 by V1 to the base E. So, W becomes equal to RT into log V2 by V1 to the base E, RT into log V2 by V1 to the base E. Changing the base from E to 10, the relation for W becomes 2.3026 into RT into log V2 by V1 to the base 10, log V2 by V1 to the base 10. We can also apply Boyle's law, hence the relation can also be written as W is equal to 2.3026 into RT into log P1 by P2 to the base 10, P1 by P2 to the base 10. We can use either of these two relations for finding the work done in the case of isothermal process. Adiabatic process. In a system, the changes in pressure and volume that take place without heat flow either from the system or into the system, is called adiabatic process. In a system, the changes in pressure and volume that take place without heat flow from or into the system is called adiabatic process. Temperature changes also take place in this process. In this process, the temperature will also change. For this process, we should take a container and piston which are made of very bad conducting material. Vessels should be used for container and piston should also be made of bad conducting material. This is a quick process. The process should be very quick as possible, so that heat will not flow out through the walls. In an adiabatic process, dq is equal to 0. Heat flow is 0, hence dq is equal to 0. From first law of thermodynamics, where dq is equal to du plus dw, we get du is equal to minus dw. du is equal to minus dw. That is, if work is done on the system, then the internal energy increases. So the temperature will also increase. If work is done by the system, the internal energy decreases. So the temperature also decreases. Boyle's law is not valid in this process. The relations that are valid in this process are PV to the power of gamma is constant, PV to the power of gamma is constant, TV to the power of gamma minus 1 is constant, TV to the power of gamma minus 1 is constant, P to the power of 1 minus gamma, T to the power of gamma is constant. P to the power of 1 minus gamma, T to the power of gamma is constant. Work done in adiabatic process. We have the relation for work done. W is equal to PdV under the limits V1 to V2. But this process obeys the law Pv to the power of gamma is constant. P into V to the power of gamma is constant. So P is equal to K divided by V to the power of gamma. By substituting this, we get the relation for work as K divided by V to the power of gamma into dV. Under the limits V1 to V2. Therefore, work done W is equal to K into V to the power of minus gamma dV. Under the limits V1 to V2. V to the power of minus gamma dV under the limits V1 to V2. By evaluating this integral, we will get W is equal to K into V to the power of minus gamma plus 1 divided by V to the power of minus gamma plus 1 divided by minus gamma plus 1 under the limits V1 to V2. Therefore, W is equal to K by gamma minus 1 into V2 to the power of 1 minus gamma minus V1 to the power of 1 minus gamma. W is equal to 1 by minus gamma plus 1 into K into V2 to the power of 1 minus gamma minus K into V1 to the power of 1 minus gamma. But we have the relation PV to the power of gamma is constant K, hence P1 V1 to the power of gamma is equal to K and P2 V2 to the power of gamma is equal to K. P1 into V1 to the power of gamma is also K and P2 into V2 to the power of gamma is also equal to K. Hence, W is equal to 1 by minus gamma plus 1 into whole multiplied by P2 V2 into V2 to the power of 1 minus gamma, P2 V2 to the power of gamma into V2 to the power of 1 minus gamma minus P1 into V1 to the power of gamma into V1 to the power of 1 minus gamma, P1 into V1 to the power of gamma into V1 to the power of 1 minus gamma. Hence, it becomes equal to W is equal to 1 by minus gamma plus 1 into P2 V2 minus P1 V1. Therefore, W is equal to 1 by gamma minus 1 into P1 V1 minus P2 V2. This is the relation for finding work in adiabatic process. W is equal to 1 by gamma minus 1 into P P1 V1 minus P2 V2. W is equal to 1 by gamma minus 1 into P1 V1 minus P2 V2. For 1 mole of a gas, PV is equal to RT. For 1 mole of a gas, PV is equal to RT. Therefore, P1 V1 is equal to RT1, P1 V1 is equal to RT1 and P2 V2 is equal to RT2. Therefore, W is equal to 1 by gamma minus 1 into RT1 minus RT2, RT1 minus RT2. Therefore, W is equal to R by gamma minus 1 into T1 minus T2, R by gamma minus 1 into T1 minus T2. For n moles of an ideal gas, work done is equal to Nr by gamma minus 1 into T1 minus T2, Nr by gamma minus 1 into T1 minus T2. Derivation of the relation between P and V in an adiabatic process. Derivation of the relation between P and V in an adiabatic process. Differential form of first law of thermodynamics is delta Q is equal to delta U plus delta W. Delta Q is equal to delta U plus delta W. Delta Q is equal to 0 in adiabatic process. In adiabatic process, delta Q is equal to 0 and delta U is equal to CV dt for 1 mole of a gas, CV dt for 1 mole of a gas, and delta W is equal to PdV. Delta W is equal to PdV. Therefore, the first law of thermodynamics, it modifies into the form CV dt plus PdV is equal to 0. Substituting dq is equal to 0, delta U is equal to CV dt and delta W is equal to PdV, we get CV dt plus PdV is equal to 0. By taking PV is equal to RT and differentiating, we get PdV plus VdP is equal to RdT. PdV plus VdP is equal to RdT, from which dt is equal to PdV plus VdP by R, PdV plus VdP by R. Substituting the value of dt we get, CV into PdV plus VdP by R, CV into PdV plus VdP by R plus PdV is equal to 0, plus PdV is equal to 0, or CV into PdV plus VdP, CV into PdV plus VdP plus RPdV is equal to 0, Rp into dV is equal to 0. By substituting Cp minus Cv for R, we get Cv into PdV plus VdP plus Cp minus Cv into PdV is equal to 0. By rearranging, we get Cv PdV plus Cv VdP plus Cp PdV minus Cv PdV is equal to 0, or Cv PdV plus Cp PdV is equal to 0. Cv into PdV plus Cp into PdV is equal to 0. Dividing throughout by Cv into PV, we get, dividing throughout by Cv into PV, we get dP by P plus dP by P plus Cp by Cv into dV by V. Cp by Cv into dV by V is equal to 0, or dP by P plus gamma into dV by V is equal to 0. dP by P plus gamma into dV by V is equal to 0. On integrating, we get log P plus gamma log V is equal to constant. Log P plus gamma log V is equal to constant, or log p v to the power of gamma is constant. Log p v to the power of gamma is constant, or p v to the power of gamma is constant. P v to the power of gamma is equal to k, which is a constant. Relation between v and t. Relation between v and t. We have the relation p is equal to RT by v. P is equal to RT by v from PV is equal to RT. And in adiabatic process, we have just derived the relation P into V to the power of gamma is equal to K. P into V to the power of gamma is equal to K. Let us substitute the value of P. Then we get RT by V into V to the power of gamma is constant. RT by V into V to the power of gamma is constant, or T into V to the power of gamma minus 1. T into V to the power of gamma minus 1 is a constant. Relation between P and T. From PV is equal to RT, we get V is equal to RT by P. We get V is equal to RT by P. And let us take the relation P into V to the power of gamma is constant. P into V to the power of gamma is constant, and substitute the value of V. Then we get P into RT by V whole to the power of gamma. P into RT by V whole to the power of gamma is equal to K. By simplification, we get P to the power of 1 minus gamma into T to the power of gamma is constant. P to the power of 1 minus gamma into T to the power of gamma is constant.